I gave you your signal report. You're 5758 with some QSB and very good audio. Aku, take it easy. Have a good weekend coming up. Look forward to the next one. Maybe we'll hear you on one of the higher bands here soon. Oscar Hotel 8 Whiskey Radio from N8XGS.
Hello, Nick here, M0NTV, and welcome back to my shack. Now, those of you that have been following the last few videos that I've made will have seen me build different bits of radios, modules, that are going to be connected together, hopefully, to produce a transceiver, SSB transceiver on 17 meters. Now, I've actually put these bits together and got it working as a receiver. Way! And you're going to see that in action today. Now, actually, what I want to do today, and apologies if this is a bit bitty today, I think it probably is going to be a little bit, because it's more of a kind of catch-up. Because I haven't done loads of videos, which I did that one the other day on the Unknown, but that was just a kind of special thing. But because I've been building basically and putting all this stuff together, so you're going to see it, and then you're going to hear it and see it in action. And then I'm going to look at two different sections of it that I've changed from previous videos that I've made, and you can see perhaps why I've done that. And then, even from recording this video, it's changed again, right? So I'm going to bring you right up to date to what it looks like today, and show you one particular thing, which is going to be the subject of my next video, which is a trailer really for the next video, because I've been a bit stuck on one particular aspect of this radio. And I've had, it's taken me a bit of a time to kind of get to the bottom of it. So I've decided to do a whole video on that. More of that at the end of this video. So, hope you enjoy. Right, well, this is the transceiver in receiver mode at the moment. And so I'm just going to kind of whiz through this and just highlight a few things that have changed. And I appreciate you won't have seen it all put together anyway, but you'll have seen bits of it being built from one video to the next. So that's the bandpass filter that we built. Now this here, this little module here is my RF preamp. It's a 15 dB amplifier. It's one of those little Wes Haywood termination insensitive amplifiers. Just uses three 2N3904s. Yeah, so that works well. So I may need to play around with that and maybe think about some kind of switching gain so I can get a bit more gain or a bit less gain. But as it's for 17 meters, I'm going to need a little bit of preamplification. That is the first mixer. Nothing changed with that. That's as it was in the video that I made about it. Then it's coming up into the IF section now. There are some changes here. This is not the same amplifier that I built in the video, and I'll say more about that. Maybe I'd do a separate video on this, but yeah. So this is a different one. It's actually two amplifiers. Just uses one transistor and a matching transformer, and with a 3 dB pi attenuator on. So that's one part of it. Then a new crystal filter, that 8th order Cohn filter. I only built that the other day because the other one, whilst it worked, wasn't the skirts weren't as steep, and so I wasn't getting a sharp enough cut off, and I was getting a little bit of opposite sideband coming through. And also I like to be able to cut out a bit of carrier as well if I can by carefully positioning the BFO, and this enables me to do that. So I'm really pleased with that. Then that's going into an identical one of those IF amps. So it's another two amplifiers with a 3 dB attenuator in between. Then the product detector, this is news, an awful lot going on there, so that will need probably a separate video or something to talk about what I did with that. And so from the product detector then, finally we go through to the audio amplifier. Well, there's an audio little preamp, and then there's the main power amp, and that's going into an old 5.1 surround sound speaker. So that's the whole thing. Oh, and I should say the in this little tin here, this is inside that tin is an Arduino Uno and an SI5351 signal generator, and that is providing my two VFO outputs for the first mixer and for the product detector. So that's what it looks like at the moment, and so I will just play you a little bit of video, just very short video that I recorded this afternoon of the thing in action on 17 meters. There wasn't a lot going on, and it was reasonably noisy, but I think you'll hear that it does in fact work.
But really good to hear you on the band today. Been a lot of good DX on 15 and 18 megs lately. The bands have been quite good. The 10 meters, my side has been very good a lot of days. It'll probably open up today as well. Things open up around 11 or 12 o'clock in the afternoon. A little bit in Europe and a lot of South America. Over.
Okay, Roger, Randy. Very good point. That's very good to hear. The band is good shape, and this time that's it this weekend. Just stopped it to work a little bit early today, and just coming in shack and turning on the radios and a little bit make some DX contact. Hi. Okay, Randy. Thanks to QSO, and best 73's happy weekend. And maybe here sometimes later future. November 8, X-Ray Golf Sierra, Ocean Henry 8, Whiskey Radio. Thank you, 73, Randy.
Thanks so much, Aku. Yeah, it's been a pleasure to hear you. I don't know if I gave you your signal report. You're 5758 with some QSB and very good audio. Aku, take it easy. Have a good weekend coming up. Look forward to the next one. Maybe we'll hear you on one of the higher bands here soon. Oscar Hotel 8, Whiskey Radio from NAXGS. Pleasant weekend.
Okay, Roger, Randy. Last over a little bit more or less S9 solid. 73s, hey.
Hey.
Okay, see.
So this is one of my two stages of my IF amplification system, and in the end, you remember the one I did the video about used a more beefy transistor and didn't put out a lot of gain, in truth. So I wasn't altogether very happy with it. Came from experimental methods in RF design, as does this one. And actually, after that video, somebody contacted me and let me know about this one, which in truth I already knew about, because I don't think I'd ever built it, but I'd obviously modelled it in LT Spice and thought about building it and never actually got round to building it. But actually in EMRFD, they do a whole thing on this and really put it through its paces and demonstrate things, distortion and various other things that you can do with amplifiers if you push them too far. So actually, there's a fair bit written about it. But if it's treated well and used properly, it's a great little circuit. Just one 2N3904 transistor, inductively loaded. You see there in the collector, and that basically takes the nominally 200 ohms impedance load on the collector to a 50 ohms. I did what I said I was going to do with the old amplifier, but never got round to it, which was to build two identical ones and then have an attenuator in between, because EMRFD said that would be the best scenario for securing a kind of constant 50 ohms on the input and the output, because it's not a termination insensitive amplifier, but this is the kind of best way of dealing with it. So and actually it puts out quite a bit of gain. So I've got a 3 dB pi attenuator sandwich with an amplifier on each side, and you'll see up the top right hand corner I was getting a bit too much power going into the crystal filter. This was the old crystal filter, so much so that it was reflecting back and going back into the mixer, and had all kinds of spurious signals and strange stuff going on. So just by knocking it down a dB or so, I was able to kind of kill that and fix that problem. So that's that. And actually, there are 3 of these pretty identical modules in this radio. This is the one that goes before the crystal filter. There's an identical one after the crystal filter, and then there's another one actually in the transmit chain, in the kind of first stage of the transmit amplifier section, where you're just beefing the signal a bit more before you send it to the driver. And I've used the same there. So actually it will take a little bit more juice, and quite pleased with that, really. So that's what I've done for that. And let me show you the new crystal filter. And this is my new crystal filter. And you'll see it's an 8th order. So there's 8 of those crystals. And now the reason I changed it was that the last one, as I said, just wasn't as sharp as it could be. And I was getting, it was fine on receive in truth, but because this is going to be a transceiver, when I was playing around with my product detector being a balanced modulator, one of the things I was realizing was that with the best will in the world, all of my balanced modulators have a little bit of carrier that leaks through. And so if you've got a crystal filter that has a sharper skirt, steeper skirt, if you carefully position it, you attenuate that carrier a little bit further and knock off some of the lower bass frequencies that you're probably not going to miss too much anyway on an SSB contact. So so that's what I did, and this works great. Now the inspiration, of course, for this was Charlie Morris, who I remembered actually on the video. I rewatched the video that he made on this, and I'll link this below, where he starts off with a 4-pole as I did, but then he links it with another 4-pole and makes an 8-pole, and it just looks a lot better. And sure enough, this works really well. So I think they, because this is for 13325 kilohertz, so I think they're 180 picofarad capacitors, all of them. The different brands, you can see the N2 are different colours, but they're all 180 picofarads. And I did exactly what I did with the last one in the crystal filters for the Fearful video. I put a 200 ohm pot on the end of each one. I had no transformers on there, 200 ohm pot, and then I tweaked it using the nano VNA so I could get the flattest response, not worrying about the insertion loss, because of course the insertion loss was horrific, having 2 variable resistors on each end, but that would always be better, I knew, once I got the transformers in. But I wasn't bothered about that. What I wanted was the flattest response, which I did. I took those pots off and measured the resistance on them, and they weren't the same. The one on the left hand side was just over 77 ohms, and the one on the right hand side was just over 93 ohms. So that's what I did. So actually these matching transformers are not the same. The one on the left has 10 turns on the primary, on the inner one, and 8 turns on the outer winding, which is the 50 ohms one. And on the one on the right has 11 turns on the primary, on the inner winding, and 8 turns on the outer one, both on an FT 3743. And that seems to do the job. And I think there is an insertion loss of, I think I wrote this down somewhere, 4.5 dB. So a little bit higher than the last one, but I can certainly live with that.
and it's 2.4 kilohertz wide. That's measured at the 6 dB points, the minus 6 dB points. So I was delighted with that, and yeah, it works really well. So so that's very good. So what I'm going to do now actually is to actually construct the IF section as Pete Giuliano calls it, a steerable IF section. That's to say that there will be one-way traffic through my IF section, but I will be directing that traffic via some relays at both ends, and so I'm going to try and stack those boards and try and make it a little bit more compact, and try and get that to work. So that's the next part of the project.
And this is what the radio looks like today. So you'll see instantly I've got a new oscillator module, VFO BFO, which is identical inside to the last one. So it's just an Arduino Uno with an SI5351 phase lock loop signal generator with an LCD 2x16 screen and a rotary encoder. So that's a bit smaller. That's why I put it in that tin like that for a bit of shielding. Now this is different. I swapped out the Wes Hayward termination insensitive amplifier and tried another one. Now this is that same circuit. You know, I said I'd use it 3 times. Well, this is the 4th time. I thought I'd try it, as I've used it throughout the IF section now. I thought I'd try just using one of those amplifier modules for an RF preamp, which gives just over 17 dBs of amplification. So what I'm thinking of doing is having a couple of pi attenuators following that, and actually being able to switch them in, so you can have different levels of preamplification. So I'll play around with that. But the main difference is, of course, this. And this is my IF stack, and it really is a stack. And if you look on the bottom, if you can see, that is one amplifier. You can probably just about see in the middle there all those crystals lined out. It's the crystal filter. Then there's the second amplifier, and on top is my steerable IF switching. And this will be the subject of the next video. So stay tuned, and hopefully that will be coming in a few days' time. So thanks again for watching. Look after yourselves, and catch you again on the next video. Bye bye.